Hello. Welcome. This is Tom Regan's 4th series of the Homestake, and this episode is Cleanup Closure 2000 to 2003. Let's welcome Tom.
Thanks, Bethany. Nice wave. Yes, indeed. This is the 4th in the series, and we'll probably take a break in December and January and pick it up after the holidays. But this is really a packed presentation. Lots and lots of information. So I'm going to go through some of the slides pretty quick because when I made this, I included a lot of detailed information that we can look at later if you want to. The slides will be recorded both by Ralph, thank you Ralph for being here, and by Bethany, so it'll be available both on Zoom and the West Hills Village site, as well as we'll be putting it on YouTube. So anyway, you can look at all those details at that time if you want to. But without further ado, let us begin. So this is about the cleanup closure, and I look at it as a kind of a turning point in the history of the Homestake mine site. From the 1878 when it started until today, that property has been utilized for many different things, mining and now science and education. And it was during the years of starting basically in late 2000 until we turned the final pumps off in June of 2003 that we closed the underground operation and did the reclamation work on all of the surface properties. And that little slice of history is what we're going to look at today, because that was the transition from closing the mine to reopening, even though during that period right up to the closure and final turning off of the pumps, there were a lot of us that worked really hard not to turn the pumps off. And we'll talk about what that implication led to. And then we transitioned into the underground, and we talked a little bit about that on the last time when we talked about economic impact and science. So, indeed, we are talking about the legacy and future of the Homestake mine, and this is talking about cleanup closure with regulatory oversight and transformation to the now Sanford Underground Research Facility, a place where science now thrives in the former mine. And just a little brief synopsis of the history from 1876 until 2001. So the life cycle of the Homestake mine really started around 1875 with the influx of placer miners in Deadwood Creek, following the ore up into the gulches around Central City and finding the outcrop of ore on the side of the hill. And development and construction of the mine continued then from 1876 to 2000. And closure, of course, started officially January 4th, 2001 into 2003 and really beyond. And you'll see a little timeline of how that kind of overlaps. I actually started doing inspections in December 1st through the 15th of 2000, just before I was severed from Homestake as an employee, and came back on January 4th as a consultant hired by Homestake and Barrick to be the cleanup closure foreman. But I started my last 15 days of as an actual employee for Homestake doing initial inspection and starting to formulate a plan for how we're going to do the cleanup, especially of the underground. So re-entry into the Homestake mine didn't then begin until 2007. And this is a Google Earth shot of the homestake property and areas. You can see the open cut, the big open pit mine that was the former mountain that is now collapsed or was collapsed and then mined out the pillars of rock that were left. The town of Lead is right in here. The Yates complex, the Ross complex, the Oro Hondo exhaust fan, and Diane and our house is right here. We lived right here. For 44 years we lived here until we moved here to West Hills Village. And this is a cross-section cartoon drawing of the underground, again showing the Yates shaft, the Ross shaft, number 5 intake, and some of the other winzes that were underground, including number 6 winze that went all the way to the 8,000. Right now, the deepest part that is being utilized is on the 4850, although there is a pump room on the 5,000 level. The water itself right now, I looked this morning, is about the 5790 foot level. And that freeboard between the 5750 or so up to the 4850 or 5,000 allows freeboard in case the deep well pump were to quit. This is a really interesting photograph showing the original open cut mining was all done by hand, double jacking, hand mucking in what became eventually the open cut. And that's how they got the rock. They would take the rock and then they would pan it and eventually would have sluice boxes and other methods to extract the gold. And this gives a depiction of what the mountain looked like on the very north part of Lead that was the homestake mine site and the city of Lead. And as they mined out underneath, you can see they pulled the rock down through what they called shrink stopes, and they didn't backfill them. Consequently, the hillside would subside, it would sink. And eventually we called it the Sinking Gardens. They had built a park and we called Sinking Gardens. And it's kind of a neat little photograph, and it kind of shows the outline of where the mountain was, which is almost as high as Terry Peak. And of course, in those early days, from the 1800s to 1900s, the only haulage equipment they had was human power and mules and horses. And this is how they lowered them underground. And some of them would spend their entire life underground. And this is a comparison picture of what the open cut looked like in the 1940s. And then in 1999, when we finished mining the open pit, you can see this little outcropping is pretty close to this one, but this top of this hill was flattened out, and you can see how it widened out about twice as wide as what this photograph shows here. Of course, this is the top of Mill Street. You can see the railroad tracks. My wife and our house would be right about here, just outside of the picture, as well as Diane's dad and mother and her sister and brother lived just around the block from where we eventually bought our house. And of course, I said it before and I'll say it again, I married a gold miner's daughter. Now this is the north side. Again, you can see the beginning of the subsidence of the open pit mine, and this is all of the mills, and this was the Star Mill, this was B&M number 1, and these were the crusher rooms, and all the other facilities on that north side. And that all subsided. All of this got tore down and the open cut sunk into that. And this is on the south east side now of where the homestake was. And this was the Yates shaft, which is still there, the Yates hoist room, and these buildings are all in place. But all of these buildings were razed, demolished, as part of the cleanup, closure, and reclamation. And we'll have some more pictures of that. And of course, here's an aerial view of the surface open cut mine, the open pit mine, and how gigantic it is. It's about half a mile wide and about 3 miles long here. It's huge, and you can see this haul road going down. And right about here, that would be about the 900-foot level. So it went just a little bit below the 900-foot level. And again, our house is right about here. Yates is over here, the Ross is over here. And again, looking back at early mining methods, this was what we called the shrink stope, and they were 100 feet between levels, 100 feet, and they would work off the rock pile, and as they would take the ceiling down, which we called the back, they would muck up that rock and take it out. And also during that time, they started doing timber stoping. These are 6-foot high sets, about 4.5 feet wide, and basically they're just like giant Lincoln logs. They're 10 by 10 tenon timbers, and it has been said that the entire amount of timber that's in the Black Hills today is underground in the same amount of quantity. There were homestake sawmills all over the Black Hills, in Mystic and other areas in the higher hills. Nemo also had a sawmill that provided the timbers for shoring up the ground that they worked on. And the reason those stopes were only 100 feet in level is because the timber could only support itself for 100 feet. And then more modern methods used electric hydraulic drill jumbos and front-end loaders. So you can see in modern methods, a big loader, you can see the guy in the cab here, to give you an idea of how big the mining operation became later. And this was kind of the type of mining, especially in my generation. I worked at the Homestake Mine from November of 1969 until my final full-time retirement and part-time retirement of November of 2024. But during the 1940s, 50s, 60s, 70s, and even into the 80s, this method of mining, called open cut and fill, was the primary method of mining, where they would mine from the bottom up, take a cut of rock out, build a floor on top of it, backfill it with rock, and build a chimney. Half of it was for dropping rock down, the other half for men to climb up and down. This was a drag line called a slusher. They would mine out this level here, scrape the rock down, and pull it out in what was called Grambies, or these were about 3-ton cars, and that was a draw chute. That was the method, open cut and fill, until later we went to mechanized mining and bigger areas, but they were all backfilled. Now here's some of these slides that have a lot of statistics that I won't spend a lot of time on, but the story here from 1878 to 2000, it says that 39,600 ounces were recovered. It's actually more closely to 44 million ounces of gold were taken out of the Homestake Mine. And at today's price, I think this morning it was $4,007 an ounce. So that's a lot of zeros at today's price. But all of these statistics give you an idea of the massive amount of work that was done. Diamond drill footage represents the exploration footage, so as they went out and explored. We talked a little bit about this last episode when we talked about the economic impact. In that December of 2000, there were 333 employees. On June of 2003, there were about 10 of us remaining. Again, more statistics about this is for just the year 2000. We recovered 171,000 ounces of gold in 2000 at a cost of $270 an ounce. Total cost was $310. So they were still making a profit when they decided to close the mine, but they needed a lot more money than that to upgrade and maintain the infrastructure. So the price of gold really dictated that they just couldn't keep the place going, you know. They had to work on the shafts and the mill and some of the other infrastructure, and they didn't have the money for it at that time. Again, more statistics. 2001 gives us a little snapshot of some of the work that was done, including $15 million that was set aside for reclamation work for the final cleanup closure. In mining, cleanup closure is the final stage of the mine life cycle. And here's a little timeline that tells you that Homestake was a very good steward of the land through all of those years. And I just picked a few of the items that we worked on even before. There was a huge effort for asbestos abatement. As you know, asbestos was used a lot for a lot of things until it was discovered in the late 1970s and 80s that it was terrible because it was a cancer-causing agent. And so there was a big effort for that. And that asbestos abatement has continued even today. In some of the old buildings, they're still doing cleanup of asbestos in some of the old buildings as we speak. In the 1990s, we did a what's called PCB mitigation, and I'm going to do a little bit of, I'll tell you about that a little bit. PCBs is an oil that was put in transformers as a coolant. And we started it in 1990 and we finished it in 2003. It took that long. And there was a real emphasis on that during the 2001 to 2003 cleanup closure, including stabilizing tailings and removal of machinery and all the other work that we're going to talk about. And then from 2006 and beyond, there were changes in water treatment, as there were all the way from the 1980s until today. So one of my admonitions, mantras if you will, is that we honor the past, look to the future, and be safe today. I was a safety specialist and cleanup closure foreman, and this was always, everything that I did was based on these three premises. And of course you can see the gold bricks that we mined. And safety ethics is about making a positive difference. And it's a cultural thing. It's doing the right thing when nobody's looking. And during those years, I was also the safety director. And during that year of 2004, that last year that I was the safety director, we had 0 Mine Safety Health Administration citations, 0 reportable injuries, and 0 lost time incidents for over 2 years. And this picture shows the annual refresher training for people that are practicing wearing one of these self-rescuer filter respirators for carbon monoxide for emergency escape procedures. So mine cleanup closure is not just throwing a switch and walking away. You know, a lot of time is spent in planning and executing the plan and being flexible enough to change as things go on. But we spent about 6 months before that December of 2000 to come up with this plan, and this is a summary of it. Policies and procedures, inspections with maps and photographs. And over here on this table I have some of the inspection maps that I used, as well as escape maps and some of the other mapping. This is the surface workings, this is the underground workings, this shows the ore body, and here's a sample of maps from the 4100 to the 4250, and another map of a really, really old working, which is above the 800 level. We called it the goat trail level because you had to climb up a real narrow path on an incline to get to it. And safety is really all about risk management. And you control injuries, you control bad things happening by either eliminating the risk, substituting it, replacing it with something else, using engineering controls, administrative controls, or PPE, protective clothing. And you can see that it goes from the most effective to the least effective. And I made this in red, all stakeholders involved in the cleanup closure project that worked for me directly, and I had about 12 people that reported to me, and that would surge based on the Warren Act, which I'll explain later what that was. But myself and all of us that were directly involved in the handling and cleanup of hazardous materials took what was called a HAZWOPER, Hazardous Waste Operations Training. It was a 40-hour class with annual refresher training to be a technician, along with all the other training that we and everybody else had in environmental health, safety, and security instructions. So mine cleanup closure includes termination of mining, decommissioning, stabilization of chemicals, rock dumps and tailings, impoundments, water containment areas, rehabilitation of the land, surface and underground, establishment and management of productive post-land use, which continues today under the direction of both the lab and Homestake and Barrick Gold, monitoring, maintenance to ensure closure success with third-party inspections, measures to mitigate and offset social economic effects, and I'll talk about what did Homestake do to help employees with this huge layoff, the 333 final employees. They had a big layoff in 1998. We went from over 1,200 employees down to 333, and we did those same things for the employees that were laid off at that time as the mine started to downsize. In many jurisdictions, financial surety is to ensure the financial resources, and that's where that $15 million came in. So planning and documentation is a big part of the beginning. Now, I mentioned the Warren Act. In the early 2000s, when Homestake Mine closed, the Federal Worker Adjustment and Retaining Notification Act required companies to give advice notice of mass layoffs. This it was designed to protect workers, families, communities from sudden loss by mandating large employers provide at least 60 days written notice. And when they got their notice, they were working underground. The underground was divided into different divisions. And as different areas were closed from all the mining activities, those employees were transferred to me for 60 days. And they worked on all of the cleanup, closure, getting equipment out, doing all that kind of work, while my core employees were working more with the hazardous materials and helping in that respect. But I kind of managed that whole thing during the closure. The Warren Act really details things like relocation, retaining and education, counseling, retirement, severance, community response, and transition. Combined legal protections, company benefits, and community solidarity help miners navigate economic loss, emotional upheaval, and cultural change, turning crisis into a foundation for renewal. And that's not to be taken lightly. I have to speak on behalf of the employees. We did not have any labor unrest. We did not have any vandalism. We did not have theft of any consequence. The employees were dedicated employees at the end and realized that this was a legacy that was going to live beyond them, and they were faithful to that. And that's to be commended not only by management, but also more especially the employees themselves that took this to heart, knowing that we had taken so much out and now it was time to give back. As I said, the crews were reassigned under the Warren Act. I had approximately 8, a few more than that from time to time. I did all the planning and scheduling, and we transitioned and reduced the workforce to about 12 in the final weeks. This is an example of some of the planning documentation. I built a spreadsheet, and every piece of equipment every area, every operation area underground, I assigned an index number to it. And on my cleanup closure maps, as I did the inspections, and I'll show you an inspection map, I would go ahead of the crews and I would document everything that was there, and based on all of our planning and recommendations from the Environmental Protection Agency and Department of Environmental and Natural Resources for the state of South Dakota, we listed everything that needed to be done and what had to be done with each piece of equipment or area. And so I had to keep track of it somehow, so I built this index system, kind of based on the Dewey Decimal System a little bit. But this spreadsheet, if you know anything about spreadsheet, you can sort by all of these headings. You can sort by what month we did the work, the index number, what level, what area of the mine, Ross, Yates, Six Shaft, that, what location, by description, or by the date that it was completed. And this spreadsheet is, I don't know, 20, 30 pages long. And then in my office, I had a pretty fair size office, and on one wall I hung up 4 foot by 8 foot that plastic board that you can write on, you know, with the grease pencils, and I one whole wall. This was before the big computer screens where I could have done it, but I'm kind of a paper person anyway, and I kind of like the idea of writing things down and looking at them and thinking about them rather than, and I could look up at this anytime, and I made a little schematic, simple schematic of the mine. Here's the Yates shaft, the Ross shaft, down to the 4850. Here's the ramp, roadway that goes all the way to the 8,000 plus different shafts that intersect. This goes from 4550 to the 8,000. And as we did cleanup closure, I would kind of mark what we had done and the dates that we had done. This whole line here is just one area. This was the 4850 neutrino project, which was a huge part of the cleanup closure, and I have some information on that a little bit later. Also, the electrical part, which included arc chute, which is asbestos, arc flash, non-friable boards inside of switch boxes, still used today. They're okay as long as they're non-friable. Non-friable means if you cut them, if you don't cut them, they're non-hazardous. If you cut them and you get it airborne, then it is a hazard. So we had to take all those out. We couldn't leave them underground to flood. Plus all of the PCB work that we did in different shops, different areas, and so forth. And I had 3 of these boards. I only show 2 of them. And then every month I had to report what we had done each month with different types of equipment. So this was a summary from January 4th, 2001 to December 31st, 2003. And in that period, we had completed 190 areas. That's levels, ramps, that sort of thing. 33 fuel storage. I'll just jump around here a little bit. Arc chute, 417 pieces of arc chute. Uninterrupted power systems, 8 of those. Bobcats, loaders, LHDs, that's a load haul dump. 45 pieces of they're front end loaders basically. Rock picks, different tenders and vehicles, fans, big fans, locomotives, and other miscellaneous equipment. So I had to report our progress with all of the equipment. We had a master sheet that showed all of those. And this map is probably, of all the maps and all the paperwork I ever did, this is my favorite. I made a copy of the cross-section of the mine, and I had it kind of squeezed together so it doesn't show the wide part of the mine, or the wideness of the mine, that is. I squeezed it all together so I could get it on one piece of paper, and this is the actual map right here. I actually have donated this to the Homestake Adams Research Cultural Center in Deadwood. I did that quite a few years ago now, as I've been donating things. And I wanted to show this to you for this presentation, so I had to borrow it. I had to sign it, I had to borrow, and I had to sign a piece of paper, it's on the back of it, that I will return that by November 22nd. I have to return it or pay the consequences. Anyway, that's the actual map there. But in that map, it just shows a ton of information. In the yellow areas were, as I would clean up an area, or the crews would clean up, I had just a paper pusher and a supervisor, so the actual work was done by the technicians and the miners. I would highlight the various levels and shafts as we completed, and it would jump around because I had people working all over the underground. And then the yellow and orange were what was done. And then as we would finish areas, we would have third-party inspections to make sure that we had quality assurance that we were following all the rules and regulations, and most importantly, that it was done correctly and we weren't going to do any foul or harm to the environment. So we figured that we would have to do at least 20% to satisfy the letter of the law. And in actuality, we did closer to 21% of all of the areas, any pieces of equipment. So I highlighted those in black, so you can see that it was just kind of everywhere. We did a good job of that. Also, this map shows in the end when we turned the pumps off. We had sensors in the shafts, and as the water would come off, those sensors would go off, and we had a reader on the surface, and we kept track of that, so we knew how deep the water was, hoping that we could get the pumps turned back on before they affected the main deep level hoists that were on the 4850 and the 4550. We didn't make it, but we'll talk about what we did to prevent lubrications from fouling the water in that closure. But anyway, so the first pump that was shut off was June 10th of 2003. That was on the 8,000 level. And the last one that we shut off was on the 1250 level on June 24th. So it took that long. It took a couple of days to get the level ready in order to turn the pumps off, and especially the 8,000. We'll talk about that a little bit later, but we only had a couple hours before the water would be up to our waist, because that was the bottom of the mine. So we did some creative things in order to get that done. In addition to the underground, we had major surface reclamation. This was the city dump. It's not a real good photograph, but it's okay. Here's the open cut over here on the right, upper right, and the mine is right here. But this is the getting ready to do the reclamation on the city dump. And the city, as most cities did, would just dump all the waste there was, and no reclamation work was done or anything like that. But Homestake decided on behalf of the city to reclaim all of this. And if you go up through Gold Run Canyon from Pluma to Lead on the left-hand side, you'll see these little terraces of green. And that's what they did, was they covered it and did the reclamation work through the EPA. Also, the surface reclamation included buildings. This is the shops and yards were either completely cleaned up or tore down or repurposed. The electrical substations were decommissioned. The insides of the shops were decommissioned. This was a machine shop. You can see these big pieces of equipment, lathes and drill presses and that sort of thing. A big building. In fact, this is the shop building. You can see how big it is, and this is what it looks like inside. And then there were other buildings. This was the former foundry where Homestake used to actually do their own foundry work, making wheels and other metal products using patterns that were made by artisans. And This was the foundry, later in the 1970s converted into a shop and warehouse, particularly for the rope crew, cage and skip repairs, and cold storage in part of it. Another big source of reclamation work is ongoing to this day, and that's the Grizzly Gulch Impoundment Dam. Prior to the 1980s, Homestake used to dump their tailings into Gold Run Creek. It would run down then to Whitewood Creek, into Deadwood Creek, and then into Whitewood Creek, into the Cheyenne River, into the Missouri River, into the Mississippi River, and make it all the way to the Gulf of Mexico. And those tailings had total dissolved solids, including heavy metals, and it also included remnants of cyanide that was used in the gold process. And it became a Superfund site under the direction of the EPA, and the reclamation took place in the 1990s, the 1980s, and a water treatment plant was set up to treat the water, and an impoundment dam was made to pump the tailings out to this big dam up in Grizzly Gulch. And it, over the years from the early 1980s until the 2000, it actually had 3 lifts added to it as it grew in size. And they were just getting ready to put a 4th lift on it when the mine was closed. But the water then was recycled, so they used recycled water, and they also had a extraction plant up there that would filter the water and get remnants of gold out of that water, which actually paid for the whole project. And in order to keep the water, they would try to evaporate the water, and that's what these are, is water sprays. You can see this water spraying. They sprayed the water up to help it evaporate. To this day, that dam is still there. There's no more cyanide, but ammonia is left over. That water is being treated at the lab water treatment plant even today. And it is mixed with the underground water. This water is cooler, the underground water is hot, but they mix it together, and as a synergy, that water then can be treated to take out the dissolved solids, and bioreactors take out any leftover ammonia and quality discharge into Gold Run Creek. And for the open pit mine, which on this map over here you can see kind of a outline of the open pit. These lines here show the depths of it. When they mined this, they created a waste rock pile, and it got so big that they had to find another area to dump the waste rock as it got bigger and bigger. So across the mountain on the north side of Central City is a gulch called Sawpit Gulch, and they filled that in, and they hauled the rock with 20-ton haul trucks across the road. That's Highway 14A, and they built this bridge. They called it a tech span, and part of the cleanup closure was to demolish this and reclaim all of that. So the cleanup closure, now we're going to focus on the underground levels and ramps. Safely decommissioning one of the deepest mining networks in the Western Hemisphere, extending more than 8,000 feet below the ground. And this is one of my inspection maps. I just randomly picked, I thought the 8,000 would be kind of nice to look at. Each one of these little hash marks represent 100 feet. So you can see how long that level is. And this is number 6 winds. And these are the different drifts. This is the pump room in the different areas where we did mining off to the sides. It doesn't show all the mining areas, it just shows the main line. And all of my little drawing or little inspection notes up here indicate areas that we needed to work on to do cleanup, closure, reclamation work. Part of that, of course, included the oil-filled transformers. This shows one of the transformers, some which had PCB, most did not, because in the 1990s we did a PCB mitigation plan. And again, I'll explain what PCBs are in a moment. But these transformer stations were decommissioned. The oil-filled transformers, if they did not contain PCB, which all but 15 sites, and there were hundreds of these transformer stations, just like a city had transformer stations, were taken out, put in secondary containment carts, taken to the top, and disposed of or sold or otherwise decommissioned. And I have a little slide on that as well. And this is what it looked like afterwards. So this is before and this is after. And of course it had to be cleaned, make sure there's no residual oils or any other hazardous materials. Equipment was tore down to its bare minimum. If the loader was an older style and couldn't be taken to the top for any valuable reason, they were stripped of all rubber, lubrications, glass, anything that could possibly harm the environment, and the metal frame was allowed to stay underground. So here's one that is just about finished. This is the front of it. This is where the bucket was. You can see one of the miners that was working on the crew picking up one of the tires to get it out. This is the shop where they're working, and that's the loader that was left underground. Then all these loaders and pieces of equipment all operated on diesel fuel. You could not have gasoline underground, it's too flammable. So we had diesel fuel storage barns, which included not only diesel fuel, but lubrications for greasing. These are grease barrels and other lubrications and so forth. And this is a fuel storage area. This happens to be a 750-gallon fuel tank that was transported, double walled for safety containment. And as these fuel storage areas were cleaned up, there was all kinds of oily muck, silt, if you will, in the bottom of them. All those had to be mucked out, usually by hand. Sometimes we could use a skid steer, and they were dumped into these double-lined rocker car, 1-ton cars, and all of that muck was sent to the surface, and it was sent out for disposal through a HAZWOPER disposal site with a whole chain of custody documenting every ounce of it, where it came from, and what was in it. This is what the fuel storage barn looks like afterwards. The false floor was removed, and the fuel storage area was washed down with a power washer. All of the water and the residuals were pumped out and put into containers, and that too had to go for disposal. And the final step was to lay down a white oil absorbent material called Spill Shark. That's the product name, and it's really a polymer. It's quite unique. It was very new in 2000, and I happened to discover it by the help of the internet, which was just beginning, but I found it, and we ordered some and tried it. And basically what it is, it's a powder that when comes in contact with lubrications of any kind, any kind of lubrication, it turns into a polymer, basically a styrofoam cup, which is almost not biodegradable. I mean, it takes centuries for styrofoam to dissipate, but it turns into little beads of styrofoam, which was allowed to be stayed underground because it's going to deteriorate so slowly that it won't harm the water if and when the water finally reaches the surface, once all of this is over 1,000 years from now. We had, in the deep level parts of the mine, we had portable air conditioning units. This is a 60-ton refrigeration unit. They all had to be cleaned. The Freon gas, they used other gases, R33 and more modern, like your car air conditioner or your house air conditioner. All of that had to be cleaned up, and all of these units were taken out. I can't remember the exact number, but I think there was close to 100 of these. There were 30-ton and 60-ton coolers all over to cool down the underground deep level parts. Again, Load haul dumps, front end loaders, drill rigs, and other mining equipment were moved from shops. You can see the size of this big shop. And this is a front end loader getting ready. This cab has a sealed cab, air conditioned, air filtered cab for the operator. And this is a drill jumbo that was drilling the rock. Again, just another view of a loader. You can see this fella here is doing the final tear down. He's taking off the safety cab over the loader. Some of the other work has already been done. The wheels are off. And this is right out at the station. You can see here's the station gate. So this is the final step. It's already on a truck, but they have to take this off. And when they hoisted these, they were too big to go on the cage. The cage was only about 4.5 feet wide and about 12.5 feet long. So they had to sling it underneath the cage to get it to the surface. Here's a skid steer. Those could be driven on the cage, and this is getting ready to leave the 2000 level. We had several underground hoist rooms, big ones and little ones. Two big ones in particular, what we call 4 winds and 6 winds. This is number 6 wind. This happens to be the skip hoist, and those all had to be decommissioned. So you can see this is a big room. This is a 12-ton overhead crane we used to lift everything off and tear it down into small enough pieces to go on the cage, or it was decommissioned to the point where we could leave it. Now this is a surface hoist. This particular one happens to be the Yates skip hoist, but there's 4 of these on the surface. We had to mothball those as well. Those were recommissioned to re-enter the underground, and they're now being upgraded with more modern electronic controls today. And at the time, we were traveling at 2,500 feet per minute. Now think about how fast that is. We could drop a cage load of 32 people in that little box, the cage, from the surface to the 4850 in less than 5 minutes. You were basically free falling once it got up to speed. Again, fuel storage areas. This is another one. You can see the 750-gallon tank and a couple of 500-gallon tanks. And this is what it looks like after we did the cleanup closure. And this is one of the miners dumping that spill shark in the fuel storage after we did all the cleanup. We also had to get rid of all the explosives that were left underground. It was cheaper, more expeditious, and even safer to just leave the explosives underground. So we removed them all into old workings, tied them all together, and exploded them in situ underground. And this is one of the small explosive magazines that had a little bit left over. These are sausages full of what's called Tovex. It's a plastic explosive that was put down holes, as well as dynamite, and in another room were blasting caps and that sort of thing. And so that's what it looked like getting ready. That's Clyde. He's thinking, how am I going to do this? Okay. And they knew what to do, and we had all the right equipment, and they went away and blasted it. And this is what it looked like afterwards. And this is kind of one of my favorite pictures as well. This was on June 10th, 2003. And if you remember, that's the day we shut off the pumps. And this is one of the pumps that we had just done the final cleanup. I mean, it was running up until about 15 minutes before this picture. We took out the lubrications, we did all of the disconnects that needed to be done, all of that sort of thing. And you can see the spill shark that we put all around it to protect the environment. And one of the guys I was with took my picture pondering, I wonder if I'll ever see that again. I don't think so. Well, you'll see, maybe some science group will come up with lots of money and we can get back to the 8,000. But I wouldn't count on it, not now. And of course, we had toilets underground, and this was a kind of a typical one. We called them red wagons, and they had a privacy curtain around them, and of course we had to get all of those out and do all the cleanup around those. Now I want to focus on PCBs. PCBs are polychlorinated biphenyls, a group of man-made industrial chemicals used in electrical equipment, paints, and buildings. In 1979, it became obvious that it was toxic. And the way it became obvious was in China, there was a village that people were using old PCB oil to fry their food in woks. And within a few years, everybody that ate from that oil got cancer. And they traced it back to that oil. And red flags went up all over the world. So PCBs are now outlawed worldwide. Again, Homestake got on board with that, and during the 1990s, we did a huge PCB mitigation plan by either retrofilling or retrofitting, changing out or changing the oil in them. And basically it talks about the environmental stewardship that was done beginning in the 1990s. So PCB mitigation, as I said, began in the 1990s. Based on these findings, Homestake has developed a cleanup plan designed to safely mitigate potential PCB impacts on the transformers. And this was based on Code of Federal Regulations 40, Part 761, Subpart N of the EPA. And again, during this time, I made this spreadsheet for all of the electrical equipment with an index number, a serial number, whether it was underground, in storage, on the surface, and all of the other vital information about them and what we did with them. Again, this is another huge spreadsheet. And this is a typical PCB mitigation sites, different substations and transformer sites. And this is the cycle that we did. We, as I said, did the hazmat training. Then we had a third party come in, and they did sampling of the concrete to see if there was any levels of PCB. And if there were, and again, there were 50, we sampled every single site where there was a transformer, whether we thought it had PCB in it or not, but we did every site. And if it was found to be contaminated, then all the concrete, the place was completely wrapped in plastic, and it became a hazmat site, and the crews had to wear level B clothing, respirators, full body suits, gloves, boots, and the whole works, with a cleanup area for themselves. And all of the material was put in barrels and set up in secondary containment. Each barrel was indexed and inventoried and set up for a chain of custody to be disposed of by, again, another HAZWOPER disposal site elsewhere off the property. And we had to document all that. Now I want to talk about, my goodness, are you with me for a little bit longer?
Sure.
Okay. This is the 4850 neutrino site. Again, I'll go through this quickly, but in the 1960s, Ray Davis established the underground laboratory at Homestake. And in 2000 to 2002, we did the cleanup work on that. And today, it's the Davis legacy, transforming a former gold mine into a world-class laboratory. So there were two neutrino sites, one on the 4850 and one on the surface. And this is just a little cartoon that says, well, why would you have one on the surface and one underground? The one underground was used deep underground in order to shield other cosmic rays out of the formula, so they could just concentrate, Ray Davis could just concentrate on neutrinos, which is a subatomic particle smaller than the nucleus of an atom. And one of the things they wanted to do was know, well, what are all the other cosmic rays that were filtering out with the rock 4,850 feet above us? So they would count all those other cosmic rays, X-rays, infrared rays, all of those kinds of things. And then they would calculate that based on what they discovered underground and take that into a factor so they weren't counting those cosmic rays against the neutrino cosmic rays. Lots of material taken out of this place. There were lead bricks used for shielding. 3,300 lead bricks amounting to 87,120 pounds that had to be removed. And some of those bricks were ballast that was removed from Mediterranean sea ships and repurposed for science in the early 1970s and 80s, brought to Homestake. And they are all stored underground to protect them from cosmic rays. And we had to put them in boxes, and we had to have a real fast turnaround to get them to another site underground to protect them from being contaminated by cosmic rays. And they figured you had about 5 or 6 days to do that. So we'd ship them to the top, had trucks ready, had a train ready, and all the logistics had to be lined up to get those lead bricks. Some of them stayed underground with or on site in a little higher level with the idea that we were going to get back underground. We kind of figured we would. Mercury, liquid mercury, which is a very dangerous chemical. I'm not going to say when I was a kid that I used to play with it, but I know some kids that did, okay?
We all did.
And we've learned that it's very toxic, it can damage your liver and reproductive organs and your brain, as you know. So there were 3,150 pounds or 293 gallons of liquid mercury. We had to get all of that out. Some of them were in small casks. There was potassium hydroxide, which is a very high level caustic, 2,300 gallons of that. Now there was the perchloroethylene, which is dry cleaning fluid, also known as tetrachloroethylene. There was 110,000 gallons in that big tank that we've talked about before. There were 28,815 gallons of mineral oil used around the project. There were electronics, laboratory supplies, tools, safety and handling equipment, and personal protective equipment. The history began with this tank. You can see Ray Davis inside the tank. That's the tank that held the 110,000 gallons of perchloroethylene. This is a schematic of the site. Here's the tank. Here's the laboratory building, the office building, if you will, where they did all the calculation. This is a ramp that went down about 100 feet below where this tank is at. This is the pump room and a little storage area over here. Here's Ray Davis on this platform right here on top of the tank. Give you a little perspective of how big that was. And of course, we always had a toolbox talk, a safety talk ahead of time. This is me and the crew getting ready. This is Fred Roebuck, a mentor of mine and safety specialist, checking for mercury using what was called a Jerome tester. And this is some of the cleanup closure pictures of the closure of the 4850 neutrino site. This is the entrance here, lots of loads, lots of full cabinets. Everything that was put down in that area from 1964 until 2001 was left there. They never brought anything up. They just kept packing it in every nook and cranny. So it took us almost a year to clean all that out of there. You can see that everything was sent up in secondary containment pans. Electronic equipment was removed. You can see this ramp with these storage platforms that were built, little walkway in between. Here's some of the electronics going up. Any hazardous material were put in secondary containment barrels. This is what the laboratory control room looked like. That's the room right there, and that's what it looked like inside. All that had to be removed. And this again is some of the material being sent to the top. This is the potassium hydroxide. Once we cleaned out all the perchloroethylene from the big tank. We flushed it out, pumped it out, but we wanted to make sure that we could get in there and spray clean it and inspect it and sample it through this portal here that we cut in the bottom of the tank. This is Steve Mitchell inspecting the infrastructure that was left there but eventually removed for repurposing the lab for now the Lux Zeppelin project. This is the submarine door at the bottom of the ramp. This is that ramp and the final removal by Randy Karsten of the final electrical wiring that had to be removed. The surface site was on the northwest part of the Yates complex, basically over the top of the 4850 site, a little bit further to the west, but close enough for government work. And that site has now been repurposed into the Sacred Circle Garden, Cinta Gleste Waikon. So the legacy is 1960s through the 1990s. The University of Pennsylvania was the primary science that Dr. Ray Davis worked for. The site of the surface site, here's the Yates shaft. Here's the office building. Open cut would be over here. The Sacred Circle Garden is right up here on top of this hill. And when we began, this is what it looked like. There was a trailer house with all of these electronics and office equipment, barrels of mineral oil, storage buildings, and there were about 22 of these vaults. And the place looked like a cemetery. These vaults were all over at kind of predetermined random sites, if you will. Here's a couple more of them. Here's looking inside, they were full of mineral oil and photoelectric receivers that would count the cosmic rays. This is the loader dismantling them. This is what they looked like after the cement was all removed from them, and then the areas were cleaned up, and this is what it looked like as we did the reclamation work around the land. And this is what it looks like today. It's an ethnobotanical garden, honors the complicated history of the Black Hills, encourages learning across generation, and supports dialogue and reflection. Then we had to seal the shafts. This is what it looks like with a camera below the Ross shaft. Each one of these are 6 feet across. And right there is a station. Every 150 feet is a station. These are 6 feet sets of steel. And that's what the shaft looks like before we did the cleanup. Not sure how to stop this.
We're going down.
Excuse me. The shaft, of course, included, once we did all the cleanup work, we had to cover the shafts for ventilation and to try to protect the shafts and protect the public by covering it and using a special foam to cover it, as well as build some ventilation walls. There was another shaft out in Grizzly Gulch below the dam called 5 Shaft. It's a round shaft. We covered it with steel. Then there's the open cut that we had to clean up. This is where we had to tear down the mill. That's where I showed you that picture of the mill. And we had to take everything out of it, clean it up, but all of the material from the mill, the infrastructure, the flooring, the steel, the siding, everything had to stay on property because it was impregnated with heavy metals and cyanide. So it was taken out to the open cut, and a couple of big pits were made in the Yates waste rock pile, and a real thick tech span plastic, if you will, was laid down, and all of the material, and you can see the material from the mill is being placed in here, and it was folded over, and all of this was folded over it. We called it a big burrito. And then all of that plastic, if you will, was welded together. It's so thick and strong that it has to be welded. It's that strong of a material. And it stays there to this day. Now, all of that land can never be used for human consumption. In other words, homes can't be built on it or anything like that. But it is a great wildlife habitat and safe for that. It's inspected monthly. This is the rock from the open cut. That's the crusher room. This is the pipe conveyor that took the rock over to the mill. And of course, the mill facility was tore down. I'll go back so we can get these on film a little better. Cleveland Wrecking was hired with this big equipment, and basically they looked like dinosaurs chewing up the mill. It was very traumatic for the town to watch this happen. Those buildings had been there for generations, and hundreds of people were up on the side of the hill. When I took these pictures, there were just people. Every day we'd go up and take pictures. And it was like watching an old friend go. Day by day, pieces were taken apart, chewed up, demolished, taken down. And again, it looked like 3 dinosaurs just chewing away. And this is what it looked like just at the end of the cleanup. You can see the equipment is getting ready to be demobilized. The area is basically cleaned up. And again, this is what it looked like before. That's what it looked like after. And this is what it looked like just before they started planting and making it into a interactive park. And this is what it looks like today.
Oh, wonderful. Thank you.
Then, through all of this, in 2002, on June 29th, we had the Grizzly Gulch fire. You've heard the song Ring of Fire? Well, that's what we had around the city of Lead and Deadwood, was a ring of fire. And this is what the mine site looked like, with the fire just just over the hill. And Diane and I put this slide in, Diane and I just lived over the hill from that. I was called in to help save the property if we could, because the fire was creeping up this hill. And I was a safety director at the time, as well as cleanup closure foreman, and I activated the mine rescue team. We got the team, they could come on the property, and we became a strike team under the direction of the United States Forest Department and the Fire Department of Lead to protect the property. And we had all kinds of fire hoses, and you can see spraying water over the hillside, and we put sprinklers on top of all the buildings to keep any sparks from starting the buildings on fire. Then, of course, after it's all done, we had to have quality assurance under the Department of Environmental and Natural Resources, later became the Department of Agriculture and Natural Resources. And these are some of the state inspectors that came in various places underground. This is a loader on the 1700. Here's a transformer site on the 2000 level. Different equipment that was abandoned and allowed to be left. And water sampling everywhere to make sure that there wasn't any contaminants in the water. Mike Rounds, governor at the time, said to determine if there are any significant environmental problems in the mine prior to Barrick closing the mine, the DENR sent teams into the mine on 3 occasions to evaluate nearly 2 years' effort of cleanup closure. All items that could adversely impact water quality or other environmental concerns were addressed in areas and equipment cleaned or removed prior to closure and final shaft sealing. Items remain underground were approved by following DENR and best practices for environmental stewardship. But we had a lot that we brought up. thousands and thousands of items. What did we do with them? We either disposed of them, repurposed them for other mines, or sold them at auctions. I need oxygen.
Yes.
And every item has a document keeping track of where it came from and where it was sent to. That's all part of the records that we have. Things like jumbos, front end loaders, surface and underground, different mining equipment, and many, many others. Then we had to make sure the pumps were all off. Nominally, the mine has about 750 gallons of water coming into it kind of naturally. In the springtime, it can jump up to over 2,000 gallons a minute. We have a water plan to do that. But we had to shut the pumps off. The exhaust fans had to be shut down and all the shafts sealed. Here's a cross-section of the ventilation system, very complex. Here's a cross-section of the 3 ventilation circuits, intake and exhaust systems. We also had a gigantic cooling plant on the 6,900 foot level that we liked to advertise it that the 2 World Trade Centers in New York City used the same systems, and this system was the same system they used to cool their 2 towers. That's how much refrigeration was used in this plant underground to cool levels from the 6,800 down to the 8,000 level. Gigantic, basically it was a gigantic swamp cooler. And we had ventilation fans, the Oro Hondo fan, the Kirk fan. We had to seal up doors. We had to seal the shaft. And again, here's the shaft that's being sealed. The pumps had to be shut off. I picked 4 of them. Here's the 8,000, the 6,800, the 36, the 24, and there were others. Other surface reclamation projects. The Yates waste rock pile was scraped down to a nominal 2% grade and covered with clay and topsoil. All timber that could be affected and water management was in place. And this is what it looked like when we were finished. An aerial view of the Yates waste rock pile. All the buildings were cleaned out. Other buildings were demolished. Diamond drill core, the exploration core, was saved for the lab. Water quality continued and continues to this day with water sampling sites that are checked weekly. Of course, we talked about the Grizzly Gulch Impoundment Dam. Stormwater controls were in place, continue to be in place, as is quality discharge of water and weed controls. This is what Sawpit Gulch looks like now, from the waste pile covered with clay and topsoil. The slime plant is now the Deadwood Mountain Grand. That was basically donated. Many pipelines that took water and slurry and so forth from the mine site to the slime plant all had to be removed and all the land cleaned up around it. A lot of the material that we had left over, especially safety material, I was allowed to donate that to the Lawrence County Emergency Management. This was in 2004 with the Lawrence County Emergency Manager, Paul Thompson. Lots of other material was donated to the Homestake Adams Research Cultural Center. This happens to be Calamity Jane's rifle that was being stored by Homestake in their vault. That was donated to the Spearfish Canyon Foundation. They have possession of that now. And of course, all of these records that we've been talking about have been donated, and I continue to donate lots and lots of records. All of this stuff that we're doing here is being recorded. All my pictures, all of this will eventually end up as part of the archives for the legacy for future consideration and research as we move forward. We also have a Stay Out, Stay Alive program. This is a surface mine portal that was blocked off. 50 feet in is a big wall that we put in. Any adits were plugged with a special foam and colored to look like the rock around it. That was a big part of it and still continues today. So that's the past. The present and the future depends on each person to make a positive difference. And that's the future as we move forward with science, education, and outreach. And in future editions of our time together, I hope to do some virtual tours of various levels underground and show you what all of the different levels look like. We'll also talk about the mine rescue team, environmental impacts, lots of fun topics to talk about. So really, this is the end, but it's really the beginning. And this is probably my favorite photograph. I call it my pickle photograph. I look like a big green pickle. This is at the bottom of that tank, the day that we pumped out the water, within hours. You can see my feet are still in some of the water. So I went back as from cleanup closure foreman to the re-entry foreman to get the mine crews back underground. And that's it for today.
Wow.
Thank you for your time and attention.